Good morning! Today will be part 2 of the DIY electric skateboard project made out of an old vacuum cleaner. First of all, now that I have my L brackets and my screws, I can now jot down where the holes will be and then I can pre-drive in the screws. But actually I am using this piece of very thin plywood, which means that the screw does not have any gripping force and that there will be a screw head coming off, which is quite dangerous. So I am going to add this piece of scrap wood, which has the width of my piece of wood. And now this will give me a gripping strength that is much better than the previous one. Also, my screws are too small for the holes in the L brackets, and thus they fall through the holes and they are useless. So I am going to use these small washers. And now it is time to attach the front wheels, which come from an old kid's bike which I have found in the trash. But actually I have found that the axle is too big for my hole, and thus I need to widen it using a drill bit. This also implies that I need to remove all my screws. I am using this scrap piece of wood as a base so that I do not drill through my workbench. The key while drilling through metals is to go very slowly and to add some lubricant, so I was using some oil so that you do not damage your blade. And using a liquid also helps the metal to cool down because it tends to heat up a lot. This process is very slow, take your time, and the key is to apply a lot of pressure on the drill. But I do not recommend getting into such a position because it is quite dangerous. Once this is finally done, I can now file the edges of my L bracket so that I get a really smooth finish. But I have also used a hacksaw in order to make the process faster. Now I can finally drive my screws in again, but actually you will have to use bigger diameter screws in order to get good gripping strength. And also I had to trim the wooden stick a bit so that I can then pass a nut between the L bracket and the wheel. Moving on, I can now tighten my wheels using a wrench, and also they are internal bearings in the wheel. This is why I do not worry about the wheel spinning and that I fix it in such a weird angle. Now we finally have the front part of the board, and since we made the rear parts in part 1, then this means that we can attach them together. And this is why I am using the PVC pipe mechanism that I have made in part 1. And I then mark holes which I pre-melt with the help of an old soldering iron in order to drive screws in. But actually I will only need screws on one side because this will be used in order to tighten the two pieces together, and the one on the bottom side I can just add some PVC glue, which is permanent. If your PVC pipes do not fit perfectly together, it is a great idea to make a DIY shim out of duct tape. So this means that I can mount the board together and drive in the screws. Now that all of this is ready, it is finally time for a first test, and I have found that the turning mechanism works rather well. But there was a huge problem. The skateboard is not sturdy enough. The plywood was bent, the L bracket also bent, and one wheel came off. That failure was a big mess and not so gratifying after so much work. But it's fine, we'll try again, learn from your mistakes. So I think that I will have to redesign everything from the ground up. And therefore I am going to do so in part 3, and this will allow me to have time in order to think about a new design which is better. In the meantime, in part 1, I could not charge my motor because basically the power supply was broken. I suspect some heat damages inside the power supply. After carefully opening the power supply with a hacksaw, since the vacuum cleaner was rather very old, it was simply made out of a transformer. And so, after having done some continuity tests with the help of a multimeter, I have found that the primary coil in the transformer was burnt and thus that there was no continuity. And rewinding a coil from a transformer is really long, tedious, and not that time worthy, so I am going to give up this power supply. But unfortunately, it was supplying 13.5 volts AC and 400 milliamps, which is quite rare for a power supply. So this means that it is pretty hard to replace and that I do not have any spares at home. And I have also found that there is a thermal fuse inside the transformer, and so basically the live current which comes from the main plug then goes into the thermal resistor and then goes to this middle pin, which then sends the live voltage to the primary coil, and then it goes back to neutral. And once I test it, I can see that the thermal fuse is not blown. But still, I do not lose all hopes, because in the plastic packaging it is written that we can supply 12 volts. Thus, I have resoldered the connectors with an old 12 volt power supply, and we will see what is going to happen in part 3. Because recharging batteries with the wrong voltage is quite dangerous. Anyways, I hope that you liked this video, or that it helped you. I will see you in part 3. Thank you for watching, and I will see you soon.